Okay, so this is going to show you how to make predictions using a line and curves of best fit. So I'm going to start by making a scatter plot, and I'm going to get my line of best fit by clicking on Customize, Series, and scroll down to hit Trend Line. But then I still need the equation, so scroll down further. Under Label, change it to Use Equation, and now I've got my line of best fit. Now notice how I have in the X column is years after 2007. I did this once where I had the years 2007, 2008, 2009 in, and when I went to make my prediction, it didn't work very well with my give me an accurate prediction. So it's much smarter to start at 0 and go up by ones, and just have it represent years after 2007. So I'm going to make a prediction for this linear trend, and I'm going to make it for the year 2027. So I'm going to sub in 20 for x into my equation. So to do that, I go equals 23.9 times 20 plus negative 9.12, or I can just go straight to take away 9.12, and I get a prediction of 468.88. That would be in millions, I believe, for the sales of Apple iPhone over time. And that fits. If you can think about this trend line going higher and higher, it's going to be up there around 468. Now I can make other predictions using other types of models. I can change the linear model to a polynomial, to a quadratic. So maybe I think it's supposed to be a parabola. So I'm going to scroll down. I'm going to change linear to polynomial degree 2, which is a quadratic. So if I do my quadratic prediction for the same year, I go equals negative 24 plus 32.8 times x, which is 20, take away 0.813 times x squared, which is times 20 squared. To get the squared, I go shift 6, 2, and that's going to predict 306. It's not as high as the linear one because it's a parabola facing down. It's starting to slow down as it goes up. And so if I want, I can continue to make other predictions. I can change that polynomial regression up to a degree 3 if I think that is a better fit. It certainly fits the curve better, but if I use that equation, you can see this curve is going to start to go down. So I would probably just to decide that that's not a good model to use, unless you had some insider knowledge knowing that iPhone sales were going to go down. And then you would go ahead and do a cubic prediction. Otherwise, you probably want to stick with the quadratic and the linear, because they at least have the assumption that the sales are going to keep going up. But if I just do this to compare, if I type in the cubic equation 3.47, take away 5.76 times 20 plus 8.35 times 20 squared, take away 0.555 times 20 cubed. And I should check that I typed that in correctly, but assuming I did, oh, that should be 20, not 29. Doesn't make my answer any better. And you can see this is a pretty bad model because I'm getting negative 1200s. But that's because this curve is starting to drop faster and faster. So I would not include that as a good model. Even though it probably has a really high r-squared value, this is a really good example of, if I click on the r-squared, just because, sorry, let me find that under series, show r-squared. So that's got a 986 for r-squared, which is higher than, I'm going to guess, higher than degree 2, 0.945, and higher than linear, 0.935. Just because it's a higher r squared value, the trend line still has to make sense if you're going to use it for any predictions.